Okay, hello to everybody. In this video we'll be taking a look at how Euclidean algorithm works. So the question says use Euclidean algorithm to compute GCD of 462 and 150. So there'll be 5 marks in an exam. Some important things to note. If you take the G away from GCD, you get CD, which is common divisor, and a common divisor is just a number that divides your two numbers. So for 12 and 6, common divisors are 1, 2, 3 and 6, because if you did all the calculations, if you did 12 divided by 1, 12 divided by 2, 12 divided by 3, 12 divided by 6, nice whole numbers, and the same for 6. If you did 6 divided by 1, 6 divided by 2, 6 divided by 3, 6 divided by 6, they all give you positive integer whole numbers. So that's a common divisor. The greatest common divisor is the largest number that can divide two numbers. So for 12 and 6, we've done it here. We've listed all the numbers, and the greatest common divisor of 12 and 6 is of course 6. The greatest common divisor also has another abbreviation, and it's the same thing as a HCF, and a HCF is a highest common factor. So the highest common factor is the same thing, it's the largest number that divides two numbers. So the highest common factor of 12 and 6 is 6. And you've seen this method at GCSE, where they give you two numbers and they say find their highest common factor, and you use the factor tree method. But here that's not going to work, because we need to use Euclidean algorithm. So what is the Euclidean algorithm? Well, the Euclidean algorithm is a way of expressing this in this form. So you want to express it in the form A equals BQ plus R, and we've got some conditions here. So A has to be bigger than B. So A and B, very simply, the two numbers you'll find in the GCD of. So A is 462, let's label that as A, and B is 150. Let's label that as B. Perfect. Perfect. Other conditions, the Q has to be bigger than 0, and R has to be bigger than or equal to 0, where Q is a quotient and R is a remainder. So how does the Euclidean algorithm look? So the first step, if we want A is BQ plus R, we take A, which is 462, and we set it equal to 150 multiplied by some number, add a remainder. And you want the remainder to be the smallest possible number. So you can just try some numbers. So 150 times 1 is 150. Try the next one up, multiplied by 2, you get 300. Multiplied by 3, you get 450. So we're getting close to the number we want now. If you multiply it by 4, you get 600, which is too big. So the number in here has to be a 3. Okay. What number goes in this blank? That's got to be a 12. The reason that has to be a 12 is because this is 450. Add 12, that gives you 462. So what does step 2 look like? Step 2, this becomes what you said equal to. So the 150 moves here, and now we express this as 12 times some number, add some number. So you try the multiples of 12, and you find that 12 fits perfectly because the next one's too big. It'd be 13, which will take you to 12 times 13 is 156, so that's too big. So 12 times 12 satisfies this. And you want the smallest possible remainder. What's the gap in here? Well, the gap's going to be a 6. So we write that in. Now, step 3 is going to be your final step of Euclidean algorithm. So you take, this number becomes here, so we've got 12 is 6 multiplied by some number and some remainder. Which numbers fill the blanks? 6 times 1, too small, 6 times 2, hits perfectly. So 6 times 2, and your remainder here, 6 times 2 is 12, so we've got a remainder of 0. Now when you've got a remainder of 0, you can stop. So everything we've done here now has given us the answer. The answer is whatever number's here, your penultimate step, when you use it, you get a 0 here. So therefore, GCD 462 150 is 6. If you're not sure whether it's 6 or 2, just divide the numbers. 462 divided by 6 will give you 77. 150 divided by 6 will give you 25. So you know that 6 will work as a greatest common divisor. You know they're both divisible by 2 because they're even, but 6 is the bigger number. So that's the GCD. So let's just recap what we did. So we took A here and we expressed it as some multiple of the other number multiplied by a quotient that will give you the smallest remainder. You did the same here. So this number turns here and this times this at this, so you get your smallest remainder. And then the same here, so 12 moves here, you get 6 times 2 plus 0. You hit a 0 remainder so you can stop, and this gives you the answer as the greatest common divisor. The two numbers is 6. Thank you very much.